Since retirement, I've been trying a lot of new things with Frank's Red Hot. It's the perfect blend of flavor and heat, like me. And it's great on all the recipes I've mastered.
It's 33.8.
Mm-hmm.
33.8. Nice. Okay, so that is going to be that was straight. So we're going to put. I'm going to round. I'm going to make that 34 to make it easy. So that's 34%. This is going to be our percentage. All right, and then that we got 95. So 95 divided by 354. Oh, by the way, did you see Amanda Gorman is going to give a poem at the Super Bowl?
Oh yeah.
You did see that?
Mm-hmm.
Cool, yeah. All right, 95 divided by 354. What's our number?
26.8 rounded 27.
26.8. Is that what you said? So round to 27. Round to 27. Yeah, that's around 27. Thanks. Ooh, geez, they talk about losing control. 27. Okay, 27. Put that there. And then finally 139 divided by
39%.
what is it?
39%.
All right, 39%. 39%. Let's make sure that all these percentages equal 100. So 34 plus 27 plus 39. That's a terrible looking 39. Does that equal 100? It has to.
Yep.
Okay, cool. Then we're good. So we've got our observed here. So let's just go ahead and work this out. So I've got expected. We expected 25 for straight. We expected 25. So we expect 25. And it really doesn't matter if you put either number in there. You know, if you could put observed minus expected divided by expected, it really doesn't matter. We're just looking at the difference between these two. So 25 minus 34 squared divided by our expected was 25. All right, what is 25 minus 34?
-9.
Okay, so 9 times 9 is, so we got to square that.
That'll be 81.
Excellent, 81 divided by 25. What is that number?
3.24.
3.24. Excellent, so that's one category. Let's do curly. Curly, we said we got 27%. And we expected 25, so that's going to be pretty close. So we got 27 minus 25 squared divided by 25. So that's 2 squared is 4. So 4 divided by 25. What is that? 25 divided by
0.16.
Point what again?
16.
0.16. 0.16. Excellent. Now we've got wavy. We said it was 39%, so 39%, and we expected, what's our expected here?
34. I think, yeah.
Oh, not 34. Remember, we did this earlier. I'm going to go here to show you where I get my expected values again. So this is C.
Oh, for wavy.
Yeah, for wavy. What do we expect for
wavy? We had 50%.
Yeah, that's going to be our expected 50 right there. So that's going to be 11. Let me set that up. So 11 squared, what is 11 times 11?
Oh, wait. I think the number for, 39. Okay, got it. Oh, so
39 minus 50 is 11.
And then square it, you get 121.
There you go. 121 divided by 25.
And then you'll get 4.84.
4.84. How many degrees of freedom do we have in this problem? How many categories do we have?
And we have 3 categories.
Yep. So how many degrees of freedom do we have?
3.
Yeah. Remember, degrees of freedom is going to be That's degrees of freedom is n minus 1. N is your number of categories. So how many?
Oh, so 3 minus 1, 2.
Yeah, so it's going to be 2. So we got 2 degrees of freedom because this is 3, right? So in this case, we're going to say it's going to be 2 degrees of freedom is 2 because we got 3 categories minus 1. So our degrees of freedom are 2. That would be an easy way to get, always think about this is an easy way to pick up a mark, because if you just know how many categories you have and they're asking about degrees of freedom, when you're writing about it, just go ahead and get your degrees of freedom calculated because that's the easiest calculation. That'll always get you 1 mark, easy. So now we need to get our sum. This is the one part we never got. So remember, the last part of this formula is easy. You just got to add them all. So 3.4 plus 1 plus 0.16 plus 4.84, what is that? Chi-squared equals
You get 8.24.
8.24. What do we do with this information? Now that I've got chi-square and I have my degrees of freedom, what do I have to do with that?
Would you like combine them together?
Okay, well, what do we measure against our degrees of freedom? I'm going to go to the intrawebs. Let's see, chi-square table. Let's see. Get this crap out of the way. I'm going to pull up a distribution table. You wrote those numbers down, right, baby?
Yes.
All right, cool. We're going to need them. Oh my God, Randy just came back. What, Randy? My God, Randy, you've been missing all the beautiful. We've been working on beautiful things, beautiful things. We just went through a chi-square problem. That was awesome. But I'm recording this, so you can go back and check it. So what was our chi-square value that we calculated?
The total was 8.24, the sum.
8.24. Okay, cool. So we got 8 chi-square equals 8.24. Excellent. And would you say our degrees of freedom? And Randy, this is the same. We're working on the same problem you were in here. You were with us before. We had curly, straight, and wavy hair. So how many categories did we have?
We have 3 categories and a degree of freedom.
Let Randy help us on that.
Oh, my bad.
We had 3 categories. That's our number of categories. So we had 3 minus 1. So what's our degrees of freedom? What's 3 minus 1, kid?
Are you asking me or are you asking Randy?
I was asking Randy. Randy. We're trying to figure out our degrees of freedom here. 3 minus 1. What's that number? Maybe she can't hear us. Let's just keep going. It's 2. So we've got 2 degrees of freedom. Which p-value did we use? Which p-value?
You talking about according to the sum or?
Well, we gotta compare. Remember, here's our sum, here's our chi-square, but we have to compare that to a critical value. But there's different columns of critical values. So which p-value do we use to figure that out? We have to use one of these p-values.
Would it be 0.1?
Not 0.1. That would mean that we were 99% unsure.
Oh, okay.
Which one shows me the certainty that I really want to have? How sure do you want to be in science of your answer? What percent sure? We always want to be 95% certain. So which one of these p-values is the inverse or the opposite of 95%? Total would be 100%. So what this is, if I were to write this in decimal form, this would 0.95. What would make it 100? I mean 1. What would make it 1, which would be 100%? What do I have to put here to equal 1? 0.95 plus something equals 1. 1 whole is 100%.
So we'll go higher in the p-value.
Well, I just want to know what 0.95 plus x equals 1. What does that, what do I have to
Oh,
put?
0.05.
0.05, that's the one we always use. So let's look. So I got here, my degrees of freedom was 2. So let's see where those meet. Right there. So this is my critical value. This is my critical value. So let's see. I've got, we said chi-square was equal to 8.4. 8.24 is what you calculate. 8.24, is that greater than or less than 5.9?
Greater than.
Yep, it's greater than 5.99. Excellent. So do we accept or reject?
We will accept it.
I would reject it. If it's greater than the critical value, something's going on. Something's going on. Something's going on. There's a statistical difference here. If my number was less than 6, this is 5.9 is 6. If my chi-square value was 6 or less, I would say, whoa, there's no difference here. But we got something that was way off. I don't know if those drawings were saved. Yeah, they're saved right here. So we saw this before. This data was way off. I think, what did we have for our percentages for curly? We got curly, straight.
Curly was 25%.
Yeah, that was our expected value. So yeah, let's put that up there. So our expected was, for curly was 25. Our expected for straight was 25. Our wavy was, our expected was 50. But you and I calculated something else. I think 50 was, this was 39, right?
Yeah,
What
39.
And what was our observed for straight?
For straight, it was 34.
34. And then for curly?
27.
27. So curly was close, but wavy and straight were off enough to screw us up. So this is, now here's the thing. How long did it take us to do this?
A process.
Yeah, a process. How long do you think it took us to calculate this?
A little bit, like while, wasn't.
Yeah, maybe like, I would think it took us just now 10 minutes to do this. Now, now this is with us talking our way through it. If you're really comfortable with it, you could go through it a lot less time. What you had to do is convert those raw numbers to percentages and then come in here and make your calculation for chi-square. When you get to the test, and you see the chi-square problem, and this is if you're in class. Now this is, I'm speaking to you, Randy. What do I want you to do with it? Well, Randy, you're going to be taking a paper version. What do I want you to do with the chi-square problem? And Turner, you won't have that opportunity to do this. You're going to have to just plug and chug and move on. Randy, what can you do, because you'll be doing it on paper? Is Randy hearing us? What would you do, Turner? Let's say you were taking this on paper. What would you do when you get to this problem?
I mean, due to it taking a while, I'll probably go back to it.
Exactly. Skip it and go back to it. Don't sit there. There's 3 marks. I'm going to unknow on the chi-square problem that I got for you guys. It's worth 3 marks. Now, some of them are easy. Which is the easiest mark that you're going to just get and move on? Which of these calculations are you going to just get and move on? Are you going to get chi-square, or are you going to calculate degrees of freedom?
Oh, you would straight up get the freedom, right? Since it's 2.
Absolutely. Since yes, it's equals 3 minus 1. Done. I mean, get that point and move. I've got 3 variables, 3 groups. I've got wavy, straight, and curly. 3 minus 1, get that mark, and then leave. When you get done with the test, come back to this problem. Don't mess with this problem if you are in class, and I'm recording this to post this for office hours. Don't mess with this until the end of the test. You're asking for a problem.
Now, is there like a chart like provided in the question?
Yes,
or-
absolutely. Yes, absolutely. I provided you a critical value table so you can see all that, no problem. In fact, I think I actually calculated chi-square width for you already. Only thing you got to do is just know what to do with it. It's actually not hard at all. You just got to look at it for a second and work on it. And it's really not that difficult, but I still, because it does take a second to get that mark, I would do it last. I'm going to see whether I can alter the order of the test so that you do that problem last. In fact, I think I'm not sure I can, but I think I can. Will you, hey, Turner, you're really good at keeping up with me. Will you text me in about 7 o'clock and say, hey, did you change the order?
Yeah, I got you.
Cool, thank you. And I'll try to fit this at the end of the test. That way that you don't fight it. All right, what other questions you guys have? Because I've got a meeting in 8 minutes.
Just to clarify for the X-Link and the auto, you said X-Link will be, you would determine that based off like the number of males or females?
Yeah, the first thing I would do is look at the number of males. If there's a bunch of males that have it and females don't, and I'm running out of time, boom, just say male, I'd say X-Link and move on. If you see it being passed from a father to a son, there's no way on God's green earth that happens. It can't happen. That's impossible. That would be the exception. And that's what we saw in that problem. If you see it being passed from a father to a son, it is not X-Link.
Okay, got it. And then for codominance, you already did that. Now, if it's incomplete, how would that go?
Incomplete dominance is where you mix them. Codominance, both are expressed. This is codominance and incomplete dominance. I don't even think I asked you anything about that, but in incomplete dominance, they're going to blend. So this, let me see if I, like right here. So in incomplete dominance, you're going to see spots. You're going to see spots. Like if you look up a roan cow, look up roan cow. See that ROAN? You'll see there'll be a spotted cow. Do you have a dog?
I wish.
Wish you had a dog? Have you ever seen a spotted dog?
Yes.
That's incomplete dominance for hair color because they're spotted.
Okay, cool. And if I just like do the quiz practices, I'll be good for tomorrow.
It's going to be, you're still going to have to put on your big girls. It'll be a tough test. It's going to let me know what's really going on with students for sure. Like who is putting in the time. And I think you'll be fine. Like you want to, if you can score above 55% on this test, then you're on track. If you're scoring below, you're going to have to redouble your efforts. The timing is exactly how you'll have it on the ID test. Now your dog is incomplete dominant if it has spots. Randy.
All right, I think I'm good, Pope. Thank you so much.
Okay, you're welcome, baby. Randy, you have a question for me? I've got a meeting in 3 minutes.
I don't think I have any questions. I was just here to, if I missed anything, from sorry, I'm struggling to put my words into a sentence. My mom said that you mentioned her